In this video, we're going to talk about solving systems of linear equations using elimination. So we've already talked about using graphing and using substitution. This is another method. Alright, so what is it? It is a method of solving systems by adding or subtracting equations to eliminate a variable. Alright, here are your steps. First, make sure the equations are lined up. So that means the x numbers are above the x numbers, the y numbers are with the y numbers, and your constants are with constants. Then I'm going to add or subtract equations to eliminate the variable with common coefficients. So that's the number that's in front of the variable. So if they have a common number in front of the variable, I'm going to add or subtract so that they eliminate. Alright, then I'm going to solve the equation for the remaining variables. And I'm going to substitute my answer into either original equation and solve for the other variable. So once I get x, I'm going to plug the x in to figure out y, or vice versa. Alright, so let's look at this example. Y equals 3x plus 4, and y equals x minus 2. So I have y's, and they both have a coefficient of 1. There's nothing there. I could put a 1 if I wanted to. So I can subtract. If I do y minus y, my y's are going to disappear. So the y's cancel. I get 0 equals 2x plus 6, because I did 3x minus x. Remember that I'm subtracting that whole equation. And then I did 4 minus negative, that changes to a plus. So 4 plus 2 gives me 6. And then I'm going to subtract 6 on both sides. I get negative 6 equals 2, divide by 2. I get x equals negative 3. So now I know what x is. I'm going to plug that into one of my equations. So if I plug negative 3 in for x, I use the second equation. Negative 3 minus 2 gives me negative 5. So my y is negative 5, and my answer is negative 3, negative 5. Alright, number 2, I have x plus 4y equals 13, and x minus y equals 3. Alright, my x's are lined up, my y's are lined up, and my constants are lined up. Now my x's both have a coefficient of 1. The number in front of the x would be a 1. Since they have those in common, I can subtract one of them away. So I'm going to subtract the whole second equation. X minus x is going to get rid of my x's. 4y minus a negative y, so that means plus another y. Minus a negative turns to plus. So 4y plus another y gives me 5y. 13 minus 3 gives me 10. Divide by 5, I get y equals 2. So now I can plug y into one of the equations. So if I pick the first one, I plug in 2 for y. 4 times 2 is 8. I get x plus 8 equals 13. Subtract the 8, I get x equals 5. So my answer is 2, 5. Alright, number 3. 3x minus 10y equals 14, and 3x minus 9y equals 15. They both have a 3x, so I'm going to subtract the 3x on the second equation. My x terms are gone. So I have negative 10y minus negative, so that turns into plus 9y. That gives me negative 1y equals 14 minus 15 gives me negative 1. Divide by negative 1. I get y equals 1. Now I can plug that into one of the equations. Wherever I had a y, I'm going to plug in 1. Solve that. I get 3x minus 10 equals 14. Add the 10. 3x equals 24. So x equals 8. And my answer is 8, 1. Number 4. Alright, so this time my y numbers have the same coefficient of 2. And I want to subtract one of them. Okay, if they're the same sign, like positive and positive, I'm going to subtract. If one's positive, the other one's negative, then that's when you'll add the second equation. Alright, so my y's are going to disappear. They're going to subtract out. 4x minus negative 2x. So 4x plus 2x gives me 6x. And then 6 minus 18 gives me negative 12. Divide by 6, I get x equals negative 2. I'm going to plug negative 2 into my first equation there. So 4 times negative 2 gives me negative 8, plus 2y equals 6. Add the 8 to both sides. I get 2y equals 14, and then I can divide by 2, so y equals 7. So I get negative 2, 7. Number 5, this is where if you see the 4 x and the 4x, negative 4x and the other one, one's positive, one's negative. So this time I'm going to add the second equation. Alright, and when I add it, they're going to cancel. 9y plus 7y is 16y. 5 plus 11 is 16. I get y equals 1. Then I'm going to plug 1 in for y into one of the equations. So I get 4x plus 9 equals 5. Subtract the 9, I get 4x equals negative 4, which means x equals negative 1. So negative 1, 1. Remember, your ordered pair should be x, then y. Alright, number 6, my y's are the same coefficient. I have one negative, one positive, so I'm going to add them. They're going to cancel. 10x plus negative 2x is 8x. 18 plus 6 is 24. Divide by 8, I get x equals 3. Then I'm going to plug in the 3 into one of the equations for x. So I get 30 minus 3y equals 18. Move the 30 over, I get negative 3y equals negative 12. So y equals 4, and my solution is 3, 4. Alright, this one looks a little off. If you look, the x, the y, and the constants are in the same place, but the equal sign is out of order. So I'm going to rearrange it, and I'm going to subtract the 3y so that it's on the other side of the equal sign. So I get x minus 3y equals 11, and then the other one is in the order that it needs to be, so it's 2x minus 3y equals 16. On both equations, I have a minus 3y, so I'm going to subtract. They're the same sign, I subtract. They're going to cancel the y's. So I have x minus 2x gives me negative x, and 11 minus 16 gives me negative 5. Change the sign of both, I get x equals 5. Now I can plug 5 in. I plugged it into that first equation, so it's 5 equals 3y plus 11. Subtract 11, I get negative 6 equals 3y, which means y equals negative 2. So my answer is 5, negative 2. Number 8, they seem to be in the right order. So I want you to go ahead and try that one. Add or subtract one of them. Your answer should be 7, negative 3. On number 9, this is all lined up. Everything's in the same order. So you go ahead and try that one, and your answer should be 6, negative 2. Right, on number 10, these ones are not in the right order. If you look, the y and the x are out of order, and the equal sign. So I'm going to move the x up to the front because I want x, then y, then the equal sign. So I'm going to subtract 2x on that first equation. So I get negative 2x plus 4y equals negative 8. The second equation is fine. Both equations have a 4y. One's positive, one's negative, so I'm going to add the equations. The 4y's are going to cancel. Negative 2x plus 5x gives me 3x. Negative 8 plus 20 gives me 12. Divide by 3, I get x equals 4. So then I can plug 4 into one of the equations. I get 4y equals 8 minus 8. 8 minus 8 is 0. So I get 4y equals 0 or y equals 0. So my solution is 4, 0. Number 11. Alright, if I look at this one, I see I have a 3x and I have a minus 4x for both equations. So since they both have the same sign, I'm going to subtract. The 3x and the 4x, or the 3x and the 4y are both going to cancel. So I'm not going to have any x's or y's. So my whole left side is going to be nothing. I have 0. And on the right side, it simplifies to 3. That is not a true statement, so I have no solution. And that means those lines must be parallel. On 12, I have something very similar. I have a 2x, and then I have a negative 2x. I have a y and a negative y. They're different signs, so I'm going to add. But the x's and the y's both are going to cancel, so I'm left with nothing. 0 equals negative 10 plus 10 is also 0. So that one's true, which means I have infinite solutions. And they must be the same line.